I'm Michael Maloney, founder of Satellite Design for Recovery.
I'm Robbie Boundy, founder of Space Impulse.
I'm Rick Ward, founder and CFO of Orbit's Edge.
And I listen to the Cold Star Project.
And I listen to the Cold Star Project.
And I listen to the Cold Star Project.
I think there's tremendous potential that we're not taking advantage of. I like to make the point that, most of the financial investors are scared to death of Elon Musk and Jeff Bezos and reusability. They figure the billionaires are doing it. They can't afford to compete. The truth is, it doesn't take a billionaire to build a reusable flight system. They're simple. If you can build a low-cost expendable launch vehicle, you can build a low-cost reusable launch system. They're really one and the same, the way you operate them. The only thing that's different is the TPS and, to some extent, the engine. I would draw an analogy for you, microwave ovens. The technology for microwave ovens dates back to World War II, but they really didn't take off until the 1970s.
Time for another episode of the Cold Star Project, the podcast and show about the challenges of scaling space firms. And I love to bring on guests who have been in the thick of it. This is Jess Sponable. He is a DARPA program manager, former DARPA program manager, in thick with the Air Force. We had to get approval for our questions and answers from the Air Force here, and I'm really appreciative of Jess here for going through that. It is a fairly long process. I think we booked this in November or December, and we've been waiting for it. We got the approval. A lot of potential guests won't go through that because it seems too onerous for them. So thank you for doing that and for being here today.
Thank you.
You bet.
Jason, good to be on.
Let's see here. I was really impressed with your LinkedIn resume, reading through it and that. You've had this super long career. Tell us a little bit about your background. I think this is going to be really relevant to space listeners.
Yeah, I'm definitely, as a general officer once called us, a flat-headed booster puke. So I've been doing space my whole career, a lot of it launch-related. Just to kind of lay that out, I started in the Air Force active duty, rose through the rank of Lieutenant Colonel, 20 years. Did a bunch of really cool programs like Global Positioning System, where we deployed the early operational satellites or prepared to deploy them. And then later the Delta Clipper Experimental, then even later a little program called X-40 that led to the X-37 that's flying today. So I have been in the thick of this as all of these various commercial entrepreneurs have taken the next step. Then after I left the Air Force, I went over and actually joined an entrepreneurial firm working for Pete Conrad, the Apollo 12 and Skylab commander, for a few years. I spent about 3 years from 1998 to 2001. Unfortunately, Pete died on a motorcycle accident and the .com busted, and so all the initiatives he tried to start went away. Then finally, I came back in the government and kind of split my time between the Air Force Research Laboratory and DARPA over the last portion of my career. So it's been a very rewarding time. I've helped mature 1,001 technologies, tried to get various programs going, and we can talk about that as we go through this discussion.
All right. Yeah. I mean, you managed over 50 contracts. And for those who haven't run into Pete Conrad yet, go to Wikipedia and look him up. Even the Wikipedia article, as dry as they can be, this one has some pretty funny anecdote sort of things in there, and you get a feeling for his character.
Yeah, he was a great man in every way. Yeah. So I did want to mention, though, that I don't work for the Air Force right now. I work for Aerospace Corporation, which is a federally funded research and development center that supports the Air Force space activities across the board.
Right, right. So with all this experience, what has been your favorite program so far?
Well, I could never break it down to just one, so let me give you two examples. The first, and by far the biggest impact of probably any air or space program ever, is the Global Positioning System program. People don't appreciate that when we started that program, how much we would learn and how it was going to take off in a huge commercial way. So we certainly didn't think it would take off the way it did at that time. We knew it was important, but we didn't think that it would take off. And I would point out the Air Force didn't even want the GPS program. It was forced on them by Congress, So Today, you couldn't take it away if you tried. They will keep it. So GPS is way up there, and there are several reasons for that. It's not just that it did great things, but it was how it was done. You know, when I went to work for GPS, best engineers in the world were working for the Air Force and the Aerospace Corporation supporting the program. They were as good as the contractor. They knew more than the contractor in many instances. I was in awe of the people I worked for.
Huh.
That you don't see that as much anymore. And then the other thing is we actually built test satellites before we deployed the operational systems. You know, normally in aircraft, you build experimental prototypes first. Well, we actually deployed 12 prototype qualification satellites and tested the whole network before we deployed the production constellation. So, and that reduced the risk, made it easier to do, brought the cost down significantly, made everything much, much easier in terms of deploying an operational capability where we knew what was going to come.
Very
challenging,
cool.
mind you. The second program, though, that I really absolutely enjoyed was the Delta Clipper Experimental. And I was the government program manager on that. I was at the Strategic Defense Initiative when that program occurred. And I got there at the beginning of the development and hung in there through the flight testing. So it was a lot of fun to work with a tight, close-knit team to develop the technologies for a complex 4-engine vertical takeoff and landing flight demonstrator. It was subsonic, but we went down there in the desert, we took it off, we threw it through 180-degree angles of attack 12 different times over 3 years, and it did a great job before it happened to land one day with wheels up. Which, by the way, there's no shame in wheels up landing. I've had classmates who ended up landing wheels up. They're not in the Air Force anymore, but it does happen. And we had the same problem, a manual error that caused it to fail and burn up. But it was always not lost, even though NASA and the Air Force didn't really pick the program up for very long. They did for a little while. The commercial sector jumped in. So, 5 gigabytes of that flight test data we distributed to Elon Musk and Jeff Bezos' teams, and they did a great job and have carried it to far greater heights.
Okay. For those who are not super familiar with this terminology, can you explain what an ops demonstrator is?
Well, we call the DCX many things, of course. On it.
Some colorful names.
An Iron Bird, it was fairly heavy, made from available materials to keep it cheap. But we also called it an ops demonstrator because the one goal of the program that we absolutely wanted to demonstrate was aircraft-like access to space. And we wanted to make sure that the operations that we demonstrated were traceable to how you would fly the follow-on systems that would come afterwards. And we spent a lot of effort trying to make sure that would be the case. So we actually demonstrated. I mean, Pete Conrad could go out there and from a cold start the vehicle up and have it flying within 4 hours. And he could have probably pushed that down to 1 or 2 hours if he really wanted to. We were actually flowing autonomously and remotely the liquid oxygen and the hydrogen. We were filling the tanks at the same time, something we don't do routinely or even at all in most of our programs today. So, and then finally, we actually demonstrated a 27-hour turnaround time. So from the time we put wheels on the ground to the time we landed the next day, 27 hours. And that was amazing. And I got to tell you, we were trying to make it happen in 8 hours, but there is a funny story that goes with that. And that is, I got a call after we finished that 27-hour turnaround time from White Sands Missile Range, telling me I had to shut down Pete Conrad because he was talking insurrection on the range. He wanted to fly 3 times in one day. And I just was on the phone back in DC, and I was talking to my White Sands Missile manager. I said, look, I'm not going to shut down the third guy to walk on the moon. Are you crazy? Let him talk. He's right. That's what we should do. I don't know if we can do it or not, but that's what we should have done.
Okay, so a lot of pushing the envelope here. You've got a story in here more about Pete. wanting to get into the craft. It was designed to be automated.
Yeah, I have a lot of really good Pete stories, but Pete argued from the beginning of the program. And, you know, when I first met Pete, he said, you know, this program really rings my bell. Fortunately, the program didn't have to pay for him. He came under McDonnell Douglas overhead. And so I could afford to have him. And he was our flight manager. And he truly did all the work of flight managing. But he had argued from the day one, both to the company hierarchy and to the SDIO leadership, that he really wanted to fly the vehicle, and we should take the parachute out of the nose and put a little cockpit in there that he could fly. And we obviously weren't going to put the third guy to land on the moon into that capsule. And also, in fairness, one of the fundamental goals of the program was to demonstrate autonomy, autonomous flight operations, which in that era was not a given. So at any rate, the first day came, we flew picture perfect, took off, rotated over, came down, and lo and behold, hydrogen being the insidious propellant that it is, a little of it got up under the lip of the nose cone and caught fire. The parachute started burning. So, you know, Pete was cool as a cucumber. He always was. Anytime he was dealing any kind of ops, man, just cool as can be, pure test pilot. And he just calls in the fire department with their water cannon, and methodically over about 20, 25 minutes, he had them put the fire out. So finally, once that was done, he sits back in his chair, rolls back, turns to me and says, "Jess, I'm just as glad you didn't allow me to fly in the nose of that vehicle," with a totally dead pin. It was hilarious. So we all cracked up.
Wow. Yeah, Pete seems to have been a hell of a guy. I mean, just reading through his rebellious streak, you know, reading through his pushback against the testing to get into the test pilot programs or the NASA programs, and that is pretty amusing. And you just see this continuing on as he goes. So after that, I guess he decided to try out some commercial ventures, and he came up with something called Universal Space Lines. What happened there?
Yeah, so Pete started an entrepreneurial company called Universal Space Lines, and also Universal Space Network. And USL was going to operate reusable space planes eventually, but in the meantime, they were going to try to do what Elon did. They were going to build an expendable launch vehicle and use that as the technical basis for building a follow-on reusable vehicle. And but he had another venture that it went with that, Universal Space Network, and that was putting up large 10-meter antennas all around the world. We had, I think, 5 of them when I left the company in 2001. And we actually were, you know, if you want to make a phone call to your satellite, instead of building your own ground infrastructure, you just dial into the infrastructure through the internet, and you program your call, and you get your data or whatever it is you need. So it's all automated, everything. It's a great concept. Unfortunately, it's really hard to get people to change, and they haven't changed to a great extent. But the program did go on and ultimately was purchased, I think, by Swedish Space Corporation. And they're still running it and doing a great job there as well. The other half of the company, Rocket Development Company and Universal Space Lines, we just could not raise enough money to go on and do what Elon did so successfully. But we're proud of Elon. We view him as a son, and we think that he's done a really good job with SpaceX and carrying on Pete's vision.
Well, very, very cool. And those Swedes, they do some good stuff. I've been trying to get the GOM space people on this show for a while. And haven't got much headway. They just seem to kind of focus on their work and whatnot. So you've managed over 50 DARPA contracts and have had a lot of experience with satellite programs. So let's talk about those for a minute.
Yeah, so over the last decade, I spent about 7 years up at DARPA a couple different times. And I ran a couple of big programs. One was called FAST, for Fast Access to Space Technology. Or Fast Access Space Technology, FAST, and it was a very lightweight solar array that, when you combine it with continuous thrust electric propulsion, would enable you to move around Earth cislunar space quickly with the efficiency of turbojets. So you're 2,000 seconds of specific impulse for the technically inclined.
Yeah.
And because the thrust is continuous and the power system is so lightweight, you could move fast between orbits. When I say fast, days and weeks versus what a chemical propulsion system too. But the interesting thing we found that as you move towards interplanetary flight, this continuous thrust capability is actually faster than chemical propulsion.
Yeah.
So we studied it a lot. We actually built a large segment of an array and tested it on the ground and demonstrated that you could do it. The other program, which I left a couple of years ago, was the experimental spaceplane program. Unfortunately, that program did not fare quite as well. Boeing carried it through approximately a critical design review, and then decided that they, although that it was technically feasible, they decided that they did not want to pursue it financially. They just had too many problems with Supermax, and they wanted to focus in on their core missions and not the future. So that was unfortunate, but it did carry along a vertical takeoff, horizontal landing vehicle concept to a next generation potential. Although I personally really like the vertical takeoff and landing concepts, I think they're superior and easier technically to do in many ways. I think that this century is going to see a lot of different reusable launch concepts happen. And that will include, obviously, horizontal lander, Virgin Galactic, and others are doing. So, other than that, I just was kind of the king of small business innovative research contracts up there. So I had a lot of small, anywhere from under $1 million to a little over $1 million contracts, maturing a whole host of new technologies. One of the more exciting ones was a very lightweight composite tank. Extremely lightweight by the standards we pursue today, probably 4 times lighter than what a typical tank would weigh, and stronger, and several other advantages of the technology. And the other key technology that was really taking off, and I had several projects on, was additive manufacturing. So additive manufacturing is allowing us to build rocket engines like we never have before. And we did some work with Aerojet Rocketdyne, as well as other companies, developing additively manufactured rocket concepts. Since I left, I've been working with a friend of mine. He actually bought it. It's a pressure-fed rocket. It's only 25 pounds of force, but it cost him $800. He additively manufactured the whole thing, and it works perfect. So, it's amazing what you can do with these modern technologies that are coming on. What cost us tens of millions of dollars to do on the DCX program, you can do today for pennies on the dollar, literally.
Hey, this is Jason Kanigan from Cold Start Tech. Thanks for listening in. I'm going to quickly interrupt the interview to talk about a new course I am offering for space startup founders. If you're a space startup founder and eventually you're looking at getting invested in, getting some of that good old venture capital pouring into the system, then you're going to need this, because I have done tons of one-on-one calls with space founders and discovered several consistent things that are just plain missing from their businesses. And these things are so important that every time a VC looks at your pitch, they're going to say, nope, no thanks, bye-bye. And so if you want to avoid that problem from happening and actually get to the promised land of being funded, then sign up. All you have to do is go to this address and drop in your email and sign up for it. It's coldstartech.com/SBM. That is for info about the course, and the first part of it will be given to you as it comes out. So go check that out. Do it now before you forget if you're a space founder. And now let's get back to the interview. And I'm curious how often you see technology get developed to a point where it could be widely adopted and then it just kind of sits there and doesn't get adopted. So how much potential have we got sitting around that we could be making use of?
Well, I think there's tremendous potential that we're not taking advantage of. I like to make the point that most of the financial investors are scared to death of Elon Musk and Jeff Bezos and reusability. They figure the billionaires are doing it. They can't afford to compete. The truth is, it doesn't take a millionaire to build a reusable flight system. They're simple. You know, if you can build a low-cost expendable launch vehicle, you can build a low-cost reusable launch system. They're really one and the same, the way you operate them. The only thing that's different is the TPS and to some extent, the engine. So I would draw an analogy for you. Microwave ovens, you know, the technology for microwave ovens dates back to World War II, but they really didn't take off until the 1970s.
Right.
We actually had a program in the 1980s called Have Region, where we built an all-metallic honeycomb structure, nearly single-stage to orbit vehicle. In fact, we built 3 structures of them, cross sections of the vehicle, not the entire vehicle, and we tested them on the ground. We're just trying to determine whether or not we could close those vehicles. We concluded that you can close the vehicles. There were still concerns about operability, but you know, those are concerns you're never going to answer until you build something and fly it. So yes, you can build these types of vehicles and you can fly them. And by the way, Elon's demonstrating that every day. You know, if you look at Elon's structural weights, it's amazing. He's building, whether you want to, I know he's doing 2-stage to orbit, but you know, if you just design them a little bit differently, those are single-stage to orbit machines. Just amazing. Now, I'm not advocating single-stage to orbit. I think commercial 2-stage makes more sense, but you know, the technology is there to do amazing things if people want to reach out and grab it. And that's also true on the satellite side.
Okay. Well, yeah, I mean, let's talk about that and the satellites and the DoD, small sats. Do you think they're getting ready to get into that field and develop small sat systems?
Well, they certainly talk about it.
Yeah.
You know, in my head, one of the first small sat systems was the global positioning system. It weighed about 1,700 pounds, but in that era, that was a small sat. So when I was a second lieutenant, we considered small sats that size, and then a little bit later as a captain, they were 1,000 pounds and less. And nowadays we talk CubeSats in kilograms, okay? But so the nature of the technology has changed dramatically. And I am hopeful that the Air Force is going to follow the commercial sector and go pursue some of these technologies for communications ISR that are involve distributed LEO constellations. But you know, we'll see what happens. They are very they have a long history of dealing with exquisite large systems, and the Air Force needs to decide whether or not it's going to go down these paths or not. My guess is they will in some cases. In some cases, they're going to need the physics of large apertures and large systems.
I'm picturing a chart with Jess Sponable's rank going up and an inverse of the satellite weight of what is a small sat coming down.
That's pretty accurate, actually. Yeah.
Interesting. Well, you really do seem to be excited about the idea of reusable launch systems. How did you arrive at that conclusion that this is the way to go?
Well, I already mentioned Have Region. So I was a happy satellite guy working out at Space and Missile Systems Center in the 1980s. And I went and joined the National Aerospace Plane Program. And NASP was trying to do a single stage orbit vehicle, but they were trying to do it with an air breathing scramjet. And the program goals were laudable. A million new technologies were advanced and matured by the program. But the technology just wasn't within reach at that time, and it still isn't today. So, and even if you could make it work, you know, what I found was I was working on a program that was classified at the time called Have Region. I already mentioned it, long since been declassified. But we were trying to build these very lightweight rocket structures and see if we could actually demonstrate that we could get the weights, and then hopefully, you know, money would follow. But the point of that program and the NAS program both was if you really had aircraft-like access to space, you could do a lot of Air Force missions differently. And in the end, it doesn't really matter whether you take off vertically or horizontally. That's a technical question, and it doesn't matter how you do it. What matters is the system reliable, supportable, maintainable, available, you know, all the things that allow us to turn commercial aircraft in hours. So I like to kind of pool all that together as aircraft-like operability. And that's what I've been pushing for many years. We can do this. And to this day see absolutely no reason why we're spending millions of dollars to get to orbit when it should cost thousands of dollars. And not that it's going to be the same cost as commercial travel, aircraft travel just yet, but it will be in the future. And there's no reason to think that's not going to happen.
Okay. Let's see. I guess we can finish up with this question. We've got all these advanced technologies at least ready to go. What if we start plugging them in? What's the impact going to be on manufacturing processes?
Oh, well, I already mentioned additive manufacturing.
Mm-hmm.
That is a revolution in and of itself. If you think about a rocket engine, has small capillaries for cooling, actively cooling the nozzle. Very difficult to make using standard fabrication techniques. Additive manufacturing, you design it in a CAD system, you send the drawing to the guy, and he plugs it into his machine, and he spits out the whole nozzle and thrust chamber assembly for you. So that is going to radically change, and has already radically changed how we build engines. I would point to Ursa Major in Colorado Springs, a small company that I worked a little bit with at DARPA. They've already got a 5,000 pound thrust engine that they're testing called Hadley. Just amazing that they've been able to do this. And they're not the only ones. There's many other companies now that are using additive manufacturing extensively in everything they do. So that's one technology. But that's not the only one. There's many other technologies, a lot of it fueled by the PC. I mean, when I started my career, we didn't have personal computers, believe it or not. I had an HP calculator when I went to college, and that was considered a phenomenal technology of the era, Nowadays you buy them in Target and they got far more capability. So everything has changed radically, and the software is slowly catching up to enable that. And it allows you to rapidly walk yourself through design iterations and come up with newer concepts and test them out on a machine before you take them to flight. There's many new manufacturing technologies that have made all of this easier.
Very, very cool. Where can people go if they want to get in touch with you? Hey, I like what I'm hearing and a lot of experience here. I want to get in touch with Jess. Where should they go?
Well, I under my consulting company, Icefox Technologies LLC, although I work for aerospace, I want to tell you, you can have to get hold of me at the Aerospace Corporation, or you can contact me at Icefox Technologies, where I go by Jess at Sponable.space.
All right. Well, that's pretty easy to remember, isn't it? You've grabbed that custom domain there. All right. My guest has been Jess Sponable, past DARPA pro. Hey, this is Jason Kanigan, the host of the program. Thanks a lot for listening to the Cold Star Project. If you want me to send you new episodes of the Cold Star Project so that you don't have to go hunting around for them or watching YouTube or anything like that, go to this page, coldstartech.com/MSB. That's short for Make Space Boring, which is what we're all about. And drop in your email address there, and I will be able to do that for you. Make Space Boring is another little show that I run. It's a shorter format, quick interviews, and news of the day, and sometimes an update of who I'm meeting and what I'm learning in the space field. It's on the same Cold Star Tech channel. Speaking of which, on the YouTube channel, I can do something I cannot do on the audio-only version, which is add playlists. And so there may be topic area playlists on the YouTube channel that you would be interested in digging into and going down the rabbit hole and learning more about. For example, space law and policy, space situational awareness, lunar mining and construction and fun stuff like that. So go check that out. That is at coldstartech.com/play. That's the short link to get there. Anyway, thanks for listening, and I look forward to talking to you soon.